this is Dr. Xu teaching mine ventilation for mining engineering college students. Today we will talk about heat stress and indices caused by underground mine heat. Human body obtains energy by metabolizing food. It requires oxygen and respiration. It is inefficient, only 20% efficiency, and most energy end up with heat. In this process, some real work is done, some heat is stored, and some heat is lost through respiration. Most heat is lost via the skin surface. The body core temperature of 36.9 degrees must remain. The body uses several voluntary and involuntary methods of maintaining this temperature. When temperature exceeds 27 wet bulb temperature, the impact on production is likely to be significant and various controls must be introduced, such as refrigeration. Above 32 degree wet bulb temperature, no significant work is possible. If the environment temperature is below 25 wet bulb, there is little adverse effect from heat, and above 32 wet bulb, no significant work can be undertaken. Study has shown that production reduces and accident rate increase with increasing thermal discomfort. Overexposure to hot environment causes different level of indices. Heat fainting occurs when a person stands still for an extended period in a warm environment. Blood tends to pool in the lower parts of the body, causing a temporary reduction in blood supply to the brain, hence a short-term loss of consciousness. A common example arises when soldiers in heavy uniform are required to remain motionless for a long period of time during ceremonial breaks. The treatment is simply to restore an adequate supply of blood to the brain by allowing the patient to lie flat in a cooler area and to loosen or remove clothing. Recovery is normally rapid and complete. Heat fainting can be avoided by intermittent body movement. The second unit is heat exhaustion. Heat exhaustion occurs after exposure to high temperatures, and it often is accompanied by dehydration. There are two types of heat exhaustion: water depletion and salt depletion. Signs for water depletion include excessive thirst, weakness, headache, and loss of consciousness. Signs for salt depletion include nausea and vomiting, muscle cramps, and dizziness. On-the-spot treatment should include removal to a cool area and administration of moderate amount of drinking water. If the patient is unconscious, then heat stroke should be assumed. In any cases, a medical examination should be carried out before the victim is allowed to return to work. Heat cramps is one type of heat exhaustion. If the electrolytic balance of body fluid is sufficiently perturbed, then painful muscular contractions occur. This may occur by salt deficiency or drinking large amount of water following dehydration. Immediate treatment may include the administration of fluid containing no more than 0.1% of salt. Heat rash is caused by unrelieved period of constant perspiration. The continuous presence of unevaporated sweat produces inflammation and blockage of the sweat ducts. The typical appearance of the ailment is areas of tiny red blisters causing irritation and soreness. Heat rash can be prevented by frequent bathing and the provision of cool living quarters. Heat stroke is the most serious heat illness. It occurs when the body core temperature rises above 41 degrees Celsius. Transmission of confused signals are generated to the muscles and organs that control involuntary reactions. Furthermore, irreversible injury may be caused to the brain, kidneys, and liver. Heat stroke carries a high risk of fatality. Current medical opinion is that the patient should not be moved until core temperature has been brought under control. The administration of first aid should include cooling by air movement and application of water to the skin. The application of CPR in cases where perceptible heartbeat or respiration are absent, and frequent sips of water if the patient is conscious. Medical assistance should be sought and treatment continued until the core temperature falls below 38.5 degrees. The patient should then be covered by a single blanket and transported to hospital. Even after physical recovery, the heat tolerance of the victim may be impaired, perhaps permanently. As we can see that the reaction of the human body to climatic variations involves a complex mix of psychrometric parameters and physiological responses. Heat stress indices are methods by which thermal environments are assessed. Heat stress indices rely directly or indirectly on data gained from experimental tests on volunteer human subjects undergoing monitored work rates in a range of environmental conditions. Over 90 indices of heat stress were developed. These reflect a large number of variables involved, the complexity of the human thermal regulation system, and the range of climatic conditions under which human beings may be required to work. The three most commonly used indices are wet bulb temperature, effective temperature, and wet bulb globe temperature. The wet bulb temperature of the ambient air is the most powerful variable affecting body cooling. Some mines retain the wet bulb temperature as a sole indicator of climate acceptability. A wet bulb temperature of 27 to 28 degrees may be employed as an approximate criterion above which work rate or shift hours should be reduced. In former years, 32 degrees has been regarded as an upper limit of acceptability for very hot mines. The second heat stress index is effective temperature. It is the temperature of still saturated air that would give the same instantaneous thermal sensation as the actual environment under consideration. Effective temperature can be read from charts for given wet bulb temperature, dry bulb temperature, and air velocity. For example, if the dry bulb temperature is 30 and the wet bulb temperature is 27, and the air velocity is 1. The effective temperature is the intersection between this line and the velocity line here. So roughly here is the temperature of about 26. The Queensland coal industry use effective temperature, so 27.2 degrees for reduced shift length and 29.4 degrees for stop working condition. The last heat stress index is the wet bulb globe temperature. It relies upon two measurements only. The first is the reading indicated by a wet bulb thermometer held stationary in the prevailing airstream. This is sometimes termed the natural wet bulb temperature. This temperature is normally greater than the aspirated wet bulb temperature. Secondly, the temperature at the center of a blackened hollow sphere, or globe temperature, is measured. And then these two temperatures are combined to the wet bulb globe temperature by using the equation below. In underground environments, use this equation. 0.7 by the wet bulb temperature plus 0.3 by the globe temperature. If it's taken on surface in sunlight, this equation is used. 0.7 by the wet bulb temperature plus 0.2 by the globe temperature plus 0.1 by the dry bulb temperature. NIOSH has employed wet bulb globe temperature as a heat stress standard and recommended the exposure limit shown on this chart at varying working time per hour. At different metabolic heat rate and different working time per hour, the limit wet bulb globe temperature can be read from here. For example, if a worker is working 60 minutes per hour and at a 200 metabolic heat rate, then the limit wet bulb globe temperature is roughly 27. Heat stress levels based on the wet bulb global temperature have also been subject to an international standard. There is a great deal that can be done to protect a workforce against unacceptable heat strain. First, the design and engineering control of the ventilation and air quality system of the mine should be directed toward providing a safe climatic environment within places where personnel work or travel routinely. If threshold limit values for climatic parameters have not been set by legislative action, then they should be chosen and enforced by self-imposed action of the mine industry. Workers should be assessed based on their health and prescription of criteria for prohibiting a person to work in hot conditions. Lastly, a workforce that is required to work in hot environments should be trained to recognize the initial symptoms of heat strain and to adopt sensible work habit. So in summary, in this lecture, we have talked about the impact of working in hot environment and the resulting unices. We also talked about the heat stress indices and how to use them to prevent workers from overexposure to heat. Thank you very much for watching. This is Dr. Xu. I will see you in the next video.